Today in the lab, how many protons and neutrons are in potassium-40? Okay, so potassium-40, this is the nucleic symbol. What's the atomic number for potassium? Yeah, 19. So how many protons and neutrons in potassium-40? Yeah, so you have 19 protons and 21 neutrons. We'll look at U-235 next time. Now alpha particles or beta particles are emitted during radioactive decay. So for the heavy elements, those are the alpha emitters. For the lighter elements, those are the beta emitters. In regard to reaction rates, radioactive decay is a first order rate process. So if you have a first order, you look at reaction rates. Okay, so if it's a first order process, that means that if we have our radioactive decay, so we have A going to products, our rate is equal to the rate constant K times A to the first power. And then we can also figure out the half-life. So the half-life is equal to a formula. And you remember what that formula is for first order reaction? It was equal to 0.693 divided by the rate constant K. So we'll use this formula today in class. Okay, so carbon-14 is a beta emitter. The half-life is 5,700 years. Write a balanced nuclear equation that shows the radioactive decay of this isotope. So for carbon-14, this is a beta emitter, so we can show an electron forming. And then there's one more product in this radioactive decay reaction. Now, to figure out what it is, the sum of the mass numbers has to be the same on each side. The sum of the atomic numbers have to be the same on each side. Okay, so that means for the second product, the mass number is going to equal 14. The atomic number is going to equal 7. So what is this element which is produced here? Nitrogen. Okay, so this is a balanced nuclear equation. Okay, so in lab today, we'll look at the second. No, actually, we'll look at a different one in lab. Let's do this one and then we'll stop. Okay, so for U-238 is an alpha emitter, so we have U-238. This emits an alpha particle. And let's see, what's the, okay, so what else is going to be produced in the radioactive decay of uranium-238? And this is the most abundant isotope of uranium. So the mass number is going to be 234, and the atomic number is going to be 94? Yeah, 90. And what's the element which has the atomic number 90? What is it? TH, okay. So, note that U-238 has a half-life of 4.5 billion years. The age of the Earth is about 5 billion years. So note that we still got about half the amount of U-238 which was present when the Earth was formed 5 billion years ago. So of those two isotopes, which one would you rather keep under your bed? Carbon-14 with the short half-life, beta emitter, or U-238, very, very long half-life, which is an alpha emitter. Okay, well, you guys can think about that over the weekend.
What do you have?
Neither.